imagine you have a metal billet or metal bar over here, alright, and then you stack it on top with another one, alright, with maybe another one on top of it, alright. So this particular middle one, alright, over here, we're going to experience a certain compressive stress on somewhere by the top of it and the middle of it, alright. And just to let you know that in this video we will not go into details, because there are a lot of terms that I really don't understand how they come from, right? And the whole thing is kind of weird, right? So I'll just go through the important stuff and derive certain stuff, alright? So let's go. So the compressive stress is actually 200 MPa, right? With the elastic modulus of 75 GPa is given. Alright, they actually ask us to calculate the stress sigma 33 with a certain formula given to you. So, and then you can also calculate alternatively using this formula by shifting sigma 33 in terms of sigma 33. Right, so just simply shift everything and then becomes this. This is just pure shifting. Okay, so now how do we actually start things? Alright, is that this 200 MPa compressive stress, right? If you were to, in fact, this whole billet over here can be in terms of a plane strain assumption. Alright, if the thickness is actually damn thin, then it's actually a plane stress. But for any case, these two are actually 2D, so it becomes like this. Alright, you have sigma 22 and sigma 11, but because sigma 22 is compressing, alright, so it's going in the negative direction, and therefore it's negative 200 MPa. So you have only one sigma 22 over here, and therefore how do you gonna calculate the rest of the stuff? Alright, and therefore what they actually do is actually to take the this matrix over here. This can be found inside your PDF over at this side, or just simply taking them out. I also take out this Lamar's constant, alright, and also the modulus of the rigidity, alright, which is G equals to this. So just bring everything out, alright. What I have is all this stuff over here, okay. And therefore, since we are actually analyzing in terms of a stress system, alright, actually you can see on this 2D system, as we say earlier, alright, because of the plane strain assumption, alright, and therefore we only have sigma 11, sigma 12, and sigma 22, alright. And please note that although we have a plane strain assumption, alright, we no need to actually use the strain formula. We can use the stress formula. It depends on what the question asks. So this is one thing that you need to take note of when attempting this type of questions, alright. And therefore now since we have this, alright, this is 2 times 2. So how do we actually so-called dissect this thing? Alright, this is in terms of a 3 times 3 system. Okay, what we can do is actually since we have no sigma 33, in fact so I'll just cancel away all this pathway over here. These are all sigma 33. Alright, epsilon 33 also cancel. Alright, maybe not. This is this middle one, is it? Yeah. And then sigma epsilon 33 also cancel. And we have sigma 12, right? Because it's our shear stress. And then sigma 13 cancel. And 23 also cancel. Alright, so the 2, 3 are all being cancelled away. Alright, and where are we? 1, 3 also cancel. Alright, so what we have left is only this should be cancelled also. So I have sigma 11, sigma 22, sigma 12, and all this stuff over here. And what is being represented over here, I'll just copy and paste it over here. Alright, you can just compare, or I just erase the stuff that we don't need. Hold on. We actually rearrange this stuff that we don't need. You can see that there is actually a similarity between here. Sigma 22 is actually your compressive stress, right? Which is 2 to the power of I think 9. Sorry, it's 200 megapascal. So it's a negative 200 megapascal, which is same thing lah. So this is sigma 22, sigma 11. The rest, as you can see, is exactly the same. Alright, while sigma 12, I'll just simply sub it inside over here. Alright, where it is the 2G over here. Alright, because this belongs to the previous, if you remember, there is something over here. Yeah, there is some values lah, right? So I'm actually removing all this, right? For what I have is this thing over here. And we wonder why my sigma 1 2 is 0 and why my string 1 2 is 0. It's because when you stack your billet, right, you're just stacking on top of each other. Alright, you are not stacking in terms of trying to do this thing, alright, or perhaps slightly away like this. You don't stack it this way, alright, because if you stack it this way, you have some shearing, right? So therefore, in this case, we have no shearing. So this is why the sigma 1 2 is 0, string 1 2 is 0, but we can still have the 2g over here. Right, the rest is simply the same thing as we have. This v, take note, is actually the lambda, your Lamar's constant. So just simply sub it in. And the next thing I want to take note is later on you need to calculate for v. Alright, it's not calculate for v, I mean you're going to calculate for this value and 2g, right? So the v is a very important value we need to know. So v is equals to 0.3 from your book. Alright, but I think it's something that deals with the material itself. Alright, I forget what is this name, but let's just continue first. Alright, as you can see, they're actually calculating 2g now. Right, we'll just take a look. So 2g is being calculated. G is actually e over 1 plus v. Alright, is your formula, and then you just simply calculate it. Right, just subbing in your stuff. Alright, E is your Young modulus, is given 75 gigapascal, and then this is your the Lamar's constant. You just sub in your own stuff, sub in your v as 0.3, you should get this thing over here. Alright, so the whole thing exactly is actually this one. Alright, what I mean is this whole thing over here is exactly this one over here. Alright, so I'm just simply subbing all the values, alright, in terms of 10 to the power of 9, because they are all at the back of 10 to the power of 9. And then the sigma 1 1, alright, because you have this block over here, this is the compressive stress that is going to compress, so there will be no strain in the 1 1 direction. Alright, the 1 1 there will be no strain in the 1 1 direction. Alright, it's only some negative 2 2 changes. Alright, because this is sigma 2 2, this sigma 1 1, so there will be a certain strain 2 2 at this portion because you're going to compress, right? So you actually compress, but you may argue that since I compress, something must come out over here, but we didn't actually talk about it, because if you come out over here, sigma 1 1 is actually not 0, but however they actually put it as 0. This is something that you should also need to know. That's why there's a lot of things that, yeah, you know, macam only. As you see, sigma 1 2, the shear stress is 0, but you can calculate your 2g. Alright, 2g is over here lah. Alright, it's actually given. This everything is already something, it's all deriving from what I've shown you just now, right? So you just take note of the first thing you need to do is just get this dude over here, and then you just, in terms of what you want to find, you just check it out. Alright, hold on. From here, since we have the values already, you can sub in your sigma 1 1, then we can also find our epsilon 2 2, and then once you get your strain 2 2 and sigma 1 1, you can use the formula that he's actually given to you over here. Alright, your sigma 1 is actually 0 because there is no strain, and then you know your sigma 2 2, you can simply sub it into this the Lamar's constant, you will get your stress 3 3. This is what we're gonna do right now. Alright, you're subbing your this is the equation that we just seen just now, right? And then the epsilon 2 2 is over here because epsilon 1 1 is equals to 0, right? So this is 0, epsilon 2 2 is simply translated over here, and then this is the Lamar's constant is over here. Alright, so therefore when you multiply, you will get this one, your stress 3 3. Alright, so your and then this is your principal stress. Alright, but in terms of this is the compressive. Alright, this is the compressive. Instead of this as a tensile, now is a value for the compressive thing. Actually, I don't think it's a principal stress. I think it's like a stress tensor only, or it's just relating to its own stress state, and that's all. Alright, then this its own stress, I mean strain state is actually using your values over here, your epsilon 2 2. So epsilon 2 2 is actually, this is epsilon 2 2 lah. Alright, the rest is 0 because there is no other strains. So this is the strain by itself. Alright, well, this is the stress where you take out from your stress tree. Okay, and then stress tree is already been found, right? It's over here. And then stress 1 is just now we have been found over here. So just simply sub in here, just let you know lah, okay, because it's like it's kind of messy over here, but just to let you know. So therefore when you have a certain compressive stress at stress 2 for example, this is the stress 2, right? And then you also have a compressive stress over here, right? This is stress 2, the stress 1 is over here, and then in fact stress 3 will also apply over here, right? Minus 86. So in fact you have all the stress acting on all the directions to some extent. Alright, so this is how this matrix is telling us right now. Right, and the only strain is actually in terms of the strain 2, alright, which is talking about this thing over here. So you're gonna compress. When you compress, the whole stuff over here is gonna be compressed. So the whole thing over here, this 3D piece over here, will be compressed. Alright, and also all the stresses will add upon this stuff over here. Alright, where the largest stresses is actually this 200 megapascal. Alright, your compressive stress acting on it. Alright, and alternatively they actually ask you to calculate in terms of this, right? And then you can rearrange, alright, because this is in terms of the sigma 3, the rest is just something else, alright? Epsilon 3 is actually 0. So we just take this formula and actually show you over here. Alright, it's the same thing. And then what we can do is simply to rearrange. Because this is 0, so if I were to bring this E out over here, E times 0 is still 0. Alright, then epsilon 3, so this one will move to the other side and therefore become a plus, you see? Sigma 1 is the same thing. So sigma 3 is equals to this thing. And you just simply calculate sigma. Since you have sigma 1 and sigma 2, you can calculate and you'll get this stress 3 over here. So this stress 3 over here is another method to calculate your stress 3, same as this method. It's an alternative method, and their values is somewhat the same, minus 85.67 and 85.7 somewhat. Alright, and this is just a brief talk about this formula, because in terms of deriving what the hell is 2G, what the hell is all this rigidity stuff, I really don't know. I just leave you to think about it, just at least to store my knowledge now. I shall see you soon.